I want to know what you know, not your neighbor. 4 months into the semester, shouldn't have to say that. No. Fair.
Yeah, I don't know why, but
No, it's fair. Said I was about Sparta kicked Dominic out of his seat when he was ding 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 dinging against his chair. So it happens. Okay. Oh, shucks. Never did that. So close.
can you hear?
I can hear lots of stuff.
Can you hear my stomach?
Oh, that's what that was?
Well, I don't know. I don't know what you were hearing, but my stomach was making some noise.
Maybe. No, I just made up numbers. Even if they come out gross, that's okay. Should be.
You did a very good job.
5, 6, 8.9, 105, 150, 185, 69. Yeah, pretty here. 95, 2. Yeah. Oh, make me doubt myself like that. Throwing a wrench in the gears. See, a couple still writing. Are we going or are we just doodling? Okay, I'll give you a minute. With that last minute, again, calendar updated. Got rid of Friday because that's tomorrow. You're blue. Blue is what we're doing. Again, we are finishing off the chapter next Friday. That's finishing off the course. That's as far as we were supposed to get, and we still got a wiggle time. Like a week of wiggle time. So, yeah. I didn't know why they thought we could only get through that for the last how many years, but I mean, we went slow, and we still got a week of time. So cool. That means we're going to have 2 days of I don't know yet. I want to talk to our Algebra 1 teachers and want to see if they want me to either get a couple extra days of practice on stuff for maybe first semester, make real sure that we got it, or if they want us to introduce a little bit about our exponential rules. Because it turns out there's extra rules to them besides just that's what an exponent means, which is the beginning of chapter 7. So a little iffy. I'm going to go talk to Jameson and company, see what they want us to do for Algebra 1. Yeah? No, that's conic sections for pre-calc. You might want to put that one back. Unless you want to look into the future of 4 or 5 years, or 4 or 5 classes, I should say. In the bin on the back wall, there should be a chapter 6 packet if you were missing one. Okay. No, because I haven't had algebra half until this year. I've always done upper math and my inclusion algebra. I haven't done algebra 1 for probably 7, 8 years because just algebra 2 pre-calc, that's my jam. I miss geometry though. I really miss geometry. That was fun. But anyway, you're in blue back there. We're going to do another set of 5 days. Quiz is on the 16th, right behind Tom's head. And after that, make sure that if you have to come in and get stuff done, like if you're gone that 16th, the next day is the 8th grade transition day, and I will have incoming freshmen for next year. So I'm actually busy during Spartan time that day, and then I'm gone on Spartan time on the 19th. So there's stuff taken up. Just make sure that if you're going to be gone for any reason, you're going to have to schedule when you're going to take care of business. Even with that, that leaves us 3 days of review, 1 day per chapter before our final. Okay? So we'll be able to review in class, going over every section, some extra practice problems. I try to wiggle it so that your review of each chapter, your final will look just like that, just different numbers. Now, naturally, we're not going to do 3 days worth of stuff in 1 day of test. I'm going to kind of pick and choose. But if our 3 days of review goes numbers 1 through 60, then on your final, it'll look the same, so you know where to look. Open notes, open everything. You can look at number 6, number 12, number 17. Like it'll be coded the same as it was on the review, so you know exactly where to look for your examples. Basically, if you lock it in for those 3 days and write notes and take care of business, you should be good to go. Which is a good thing because I was looking at the attendance reports and some of you already have to pass the final to get credit for the class. So that would suck to be sitting at a D or a C technically, but you don't get credit for the class because you didn't pass the final. I got a couple who did that first semester and they have to show me a 70 this semester to get credit for the class. So those 3 days are going to be a paramount for you. But that's all that stuff. Everyone's done with the thing. Here we go. If I were to stack these two together and just add things, right now nothing disappears. The whole point of elimination was to eliminate a variable. Nothing eliminates now. I can't take 5 times the thing to make 3, 3 times the thing to make 5, 2 times the thing to make 7, 7 times the thing to make 2, unless I go to fractions and decimals. And most of you despise that. So this would be one of those things where maybe it's better to do double multiplication so you don't have to have fractions and decimals. Okay, now Bailey, you would ask, could I multiply by 3.5? I know you're eyeballing this guy, let's get rid of 7. That works. I could have multiplied this by 5/3. This whole equation by 5/3, and it would have gotten rid of it. But I know y'all don't like most of that. So most of us probably would have multiplied both equations. Who got rid of x's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, okay, there's the majority. So let's get rid of x's. What is the number, smallest if we can, that both 5 and 3 go into? My least common multiple. I'm going to take this thing times 3 and this thing times 5. Why not one of them negative? I've already got a positive negative. And that's always a bonus. I personally choose the positive negative pair so I don't have to screw up my negatives. Okay. 3 times the stuff, negative 15x. 3 times the stuff, plus 6y. 3 times the stuff, negative 69. Obligatory freshman noise. 5 by 3x is 15x. 5 by negative 7y, negative 35y. 5 by 37, 151.85. And now something does actually eliminate. My 15x's go bye-bye. And I have negative 29y is, what was that, 16? 116? Yeah, 116. And I divide and I get 4. Just done. No, well, negative 4, right? Okay. Whew. Defense. Okay. I got y as negative 4. What do I do with it?
You have to plug it in to find x.
I've got 4 options. What do you want to plug it into?
Still at the bottom.
Okay, I heard 2 people say the bottom original, so I'll use that. I'll say 3x minus 7 of these is 37. And I just said the these is negative 4. So, clean it up. 3x plus 28 is 37. Subtract 28 for both sides. 3x is 9. Divide by 3 on both sides. X is 3. Again, at the very, 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 very end of this, if I were to graph these two, they would cross at the point 3, negative 4. So let's make sure we're writing that as a coordinate. Unless, of course, they're talking about word problem, context of word problem. Remember, the question at the end might say something like, how many squirrels fell over drunk? Like, it's going to have a context, and you have to answer the question. Okay? Y'all know the whole fermenting fruit thing, right? Fruit lays on the ground too long, it ferments and basically turns into really nasty alcohol. Animals get drunk on it. My wife and I used to park the chair in the front yard and watch the squirrels in the park across the road. Up the tree, thump. Up the tree, thump. Fun to watch. Point wise, let's say, because you could have multiplied by whatever, and you could have gotten whatever. It's going to be by process. Step 1. Did you distribute into the entire equation correctly to eliminate a variable? So kind of 2 for the whole multiplication and add them together process. Did you get the correct first variable? Because if you eliminated y's first, you would have gotten x instead. Did you plug it back in to get the other variable? And if you got this correct, you should have had the coordinate at the end. Okay, so 2 for the initial distribution, 3 for the solving process, 1 for the final answer kind of thing. Okay, anything about it? Who'd you all have on Tuesday? Oh, wow, they were really shorthanded. Okay. Where'd you go? There we are. No, I don't even remember what it was. We had an appointment of some kind, so had to go do a thing. Anything? Got plenty of time. That is true. Okay, you had 2 days. If you were going to ask questions, sometime in the last week, you should have been asking questions. Come by, doing some extra practice, something like that. Okay? So, then, here we go. I always completely miss this corner. Womp, womp. Womp. Let's get a real calculator. If you don't like the bumblebees, I've got other ones. Okay, everyone got? Hi.
I have a question.
What?
So, like, for this one, since this is a -1, can you just times the bottom one by? Hold on. So this is
How about we wait until we get to that one? All right. 6-1 through 6-3. 6-1 we only spent 1 day on because coming fresh out of chapter 5, how to graph an equation should have been pretty fresh in our minds. Can you graph 2 lines and tell me where they cross? Now, this, do you know how to graph by intercepts? We went through it. Remember, if I put a 0 in for y, I get 3x is -6. Divide by 3, I get an x-intercept of -2. Do the same thing the other way. Shove a 0 in for x. Divide if you have to. Get a y-intercept of -6, which is 1, 2, 3, 4, 5, off-road. But I do still see the pattern of down 6, right 2. I can use that to up 6, left 2. Or I could cut that in half to get my slope of down 3, right 1. If you know how to graph by intercepts. You don't have to. I think most of us were probably more about the y equals mx plus b life, where I would subtract 3x. Some of us live or die by that divider line. Zeroes out, and I get y is negative 3x minus 6, because these are not like terms. Well, can't I start with negative 6? Have a slope of negative 3, which is down 3, right 1. Or, if I can't do that, then I swap it to up 3, left 1. From there, up 3, left 1, up 3, left 1, up 3, left 1. Okay? Do the same thing here if you want to rearrange that. I'm going to add x. We live or die by that line. Different color. I'll go with it back to yellow. Zero it out, and sometimes I'll get a little bit lazier. I forget, algebra half, algebra 1. I need to be shown every step. So if I don't, and you wonder where something came from, you got to stop me. If you put that 0 in there, if negative x plus x is 0, and you put the 0 on it, you should see the negative is still with 2y. And that's one of those little things that we just tend to screw up until we get enough experience with it. And basically until you screw it up enough times. There's still a negative there. Don't forget it. These are not the same kind of critter, so they just hang out awkwardly next to each other. Y is still not by itself. Divide everything by negative 2. What else do I divide by negative 2? Everything. Math is communist. What you do for one, you do for all. Okay? Like genuine communism, not like fake media communism. Okay? So I get y is, what number is in front of that x? So make sure you say it's a negative 1/2 x. Okay? And then plus 3/2, or 3/2 is also 1.5. And you say, well, this has got all kinds of fractions in it. How's it ever going to meet up with this one? Because if I start at 3/2 and I follow my process, up 1, right 2. Oh wait, it was negative. Other way. Hear the sigh of exasperation. Ah, so close. Up 1, left 2. Up 1, left 2. Up 1, left 2. If I keep that pattern going, it turns out that it actually does hit right there. Now, some of you, throughout the last, month and a half, since we started chapter 5, 2 months, some of you get a little loose with your graphs. Use graph paper. Make a lot of points. Use a straight edge. For crap's sake, you should at least have an ID on you. A Dairy Queen gift card, something. Your permit. Driver's license. You can get driver's license at 14, right?
Yeah.
Okay. Every state's different. Make sure you use a straight edge, because if you're not careful with where you line these up, it might not look like it hits this point. You have to be careful. You have to be precise with it. And then the directions say solve the system. They don't just say graph the system. So make a note next to this so you don't get the dumb points off or just, oops, I didn't read the instructions. Actually write the coordinate. Where is the solution? That's at -3, +3. Now, just because I can't put the entire section worth of examples on number 1, what happens if They meet in the middle of a box, out in no man's land. You're going to have to ballpark it. How do I know if I'm right? Right? I should be able to put these in for X and Y, and it makes them work. So you ballpark it, throw it in, they should work. What if I get this? No solution. They never cross. There's no place they're both going to be happy. Well, what if I go to graph 1, maybe by intercepts, I range the other one into slope-intercept form, and it lands on the same line? Okay, be careful that it's infinitely many, not all real numbers. All real numbers would be if this worked too, and it doesn't. So it's infinitely many. All right, so the first section was just, can you graph lines? Coming out of chapter 5, we should be able to. And then we did 2 days on substitution. Solve by substitution. The idea behind substitution is I can substitute one value, one variable, with a whole bunch of stuff. But I need to get one of the variables by itself to do that. So would you rather get this x by itself or get this y by itself? Okay, I'm hearing x's. So I'm going to take this guy off to the side, have a little chat with him. I subtract 2y. I always forget until after the fact. Live or die by that line. See, the reason I say that is because I'll still see kids do this. Like, they won't put the 1 over here. They'll just put the 2 on the same side. All right, just be careful. If you take 2 away from this side and then 2 away from this side again, it's just not even close. That line shows me that I'm doing the same thing on both sides. All right, zero's out. I now have x. Not the same critter, they just sit next to each other, awkward-like. Kind of like when you get paired with that one kid you absolutely hate in science. If x is this stuff, see a couple of you nodding very, very fervently. If x is this stuff, what do I do with it? In the other equation. Boy, that's a good note to write. Plug it into the other equation. Never put it back into itself, or it'll tell you infinitely many solutions every time, because the line is the solution to itself. So I'm going to say -3, it ain't x anymore. It's this stuff. And this stuff is -2y minus 6. Color. Here we go. Well, what now? Okay. Disturb it. -3 times the stuff. 6y. -3 times the stuff. Plus 18. Still got a y there. And again, that divider line might be what makes or breaks you. Because if I look at my terms, again, I will see kids year after year try to say minus y minus y. I'll have kids do that all the time. You see how you took y off of the same side twice? You've all been on the teeter-totter when one kid jumps off. Okay? You're getting cracked in the nethers, and no one likes that, unless you're a masochist. I need to do same side for combining like terms, or maybe just combine like terms and then start moving things. Oh, did I bring up bad memories? Good memories? Oh. And then, okay, I know a good chunk of you weren't in here last semester, but boy, did we like the words, the Who's Lonely game. Okay? Who's all by themselves, hanging out in their mom's basement, trolling people on Reddit? -10. So you need to bring him a date. Otherwise, he will continue to live in his mom's basement forever, trolling people on Reddit. And when I say bring him a date, I mean a like term. You bring an 18 over to a 10. You don't bring 7y over to a 10 because I need companionship. Okay, here's a pizza. Like, that doesn't work, right? Zero's out. 7y is -28. And finally finish it off by dividing. Now, I say finish it off. Maybe another note to write to yourself. Just because you get there doesn't mean you're done. We're so used to getting x equals number, y equals number, and we quit. Oh! You found y. You should probably find the x that goes with it. So, well, I got options. Where do I want to put that y? Okay. I already moved stuff around. I already got x equals junk, so I will put it into that one because odds are it's going to be easier than plugging it in here and solving. So I'm going to come back here and say x is -2, y minus 6. I just said y is -4. Finish it off. X is 8 minus 6, so x is 2. Write your final answer. To -4. I don't know about you, but to me, substitution just seems like a lot more work. It depends whether it's set up for it or not, I guess. Sometimes it's set up for substitution, and that is faster if something's already by itself. But if it's not, there's a bunch of extra work to do. I would much rather use elimination if at all possible. So yeah, I could get y by itself, plug it in, and do what I just did. But, did we figure it out this time, Amy? You're kind of arguing with yourself there.
Oh, yeah.
What are we multiplying by? Like, you could do anything. You could get rid of x's or y's, but what would be the safest and quickest? The y, because I only have to multiply one thing instead of two. Also, I already have plus minus, so that's working in my favor. So I'll take the top equation times 5, and I have always felt better about just rewriting them instead of trying to scribble, because here's what I mean. I'll have kids who say 5 times like this, and I'm even going to do it all in white so it's the same color and you see why it's nasty. They say 10x minus 5y is 80, and then they try to work across this. We've talked about transference in here before. Someone's talking to you as you're typing. You know, the 3 most important capitals in the European Union are, dude, where are you going for lunch? Where things invade your thought process. If I try to say -5 plus 5 is 0, how many of us are accidentally going to say 10 plus 2x? How many of us are accidentally going to say 2x plus 3x if I write it up there? Okay, instead, save yourself that heartache and write over here so you can actually show the distribution process. So you can show the distribution process. because now I can just drag this one over and it turns out everything's nice and crystal clear. My y's disappear. 13x is 91. Divide both sides by 13. X is?
7.
Okay. I just said X is a thing. Go back and find out why. Which one you want to plug into?
Wow. Yeah, the bottom.
I like the bottom one because it's got positive numbers. Less for me to screw up. Also, if I use the top one, I run that risk again as my eyes travel downward of accidentally picking up the wrong number. So I'm going to say 3 of these plus 5y is 11. In there goes 7. Getting purple. 21 is plus 5y is 11. Play the Who's Lonely game. Maybe we'll get that line up here again. Subtract 21 from both sides. Show the 0. Because if there's a negative in front of that 5, you want to catch it. They are the same kind of term, so combine them. Divide. Again, write the coordinate. 7, negative 2. Okay. Substitution, it's good, it's got its purposes. I'll tell you, most teachers, most textbooks, most contexts of problems will use elimination. In fact, I got pre-calc just tomorrow, next week, starting 3 and 4 variable systems by a special type of elimination called matrices. Okay, it's just a big box full of numbers. You just got to move around rows and columns and multiply and add over and over. Okay, you look like the meme of what's his face from The Hangover trying to count cards at the casino. It all comes back to this skill, which is why I have 2 types of elimination on the test. Because you can eliminate by 1 multiplication, or sometimes, unless you're willing to go to fraction town, you have to multiply twice to get rid of things. I'm betting you don't want to use fractions on here. You can, it's legal, but most of us would rather say, no, I'll just get rid of x's or y's by double dipping. So, would you rather get rid of x's or y's, and what is your reasoning? Why? Okay, not only are they smaller numbers, but minus plus. They're already opposite signs. If I don't have to multiply by a negative, that's one less thing for me to screw up. So, I'll take each one times a thing. If I'm getting rid of y's, I probably want a number that both negative 3 and 4 go into. 12. 12 is the smallest of the bunch. So top one by 4, show it. Show that it's 28x minus 12y is 8. A note for yourself with this, don't forget to multiply across that equal sign if you're doing it like this. One of the most common errors, just missing negatives, but the other one is I multiplied the first term, maybe even the second term, forgot the third one. This one by 3, getting 15x plus 12y is negative 51. All right, my y's cancel out. Bye-bye. Add these two together. 43x, prime number, ew, but negative 43 on the other side. Divide by 43. You're halfway there. Whoa, whoa. I said X is stuff. Go back, shove in X to find stuff. I'm just going to use bottom one because, again, we've got positive numbers. It's right here. 5 of these plus 4 of those is negative 17. I just said X is negative 1. So, negative 5 plus 4y is negative 17. New color. Add 5, add 5. Play that Who's Lonely game. Zero it out. 4y is negative 12. Divide. Alakazam. Again, write your coordinate. Take it all the way to the end zone, and then do your dance. So 1 graph, 1 substitution, 2 elimination. Words are hard. Like, not just the I flubbed my words. Words are hard, but genuinely word problems can be hard. Do you all have that, what was it? That one slide or that one page of notes where we wrote out our 3 different forms? Slope, intercept, point, slope, standard form, and how they all look with word problems. Okay? Travel agency offers 2 Boston outings. Plan A, hotel for 3 nights, 2 pairs of baseball tickets. Worth $556.40. See how there's an entire sentence that said thing and thing with equals a total. Thing and thing total. Which form is that? Yep. Yes, ma'am. We have AX plus BY equals C, or rate X plus rate Y is total. So, write it out. I've got 3 nights of hotel. Oh, maybe I should put off to the side what this stuff is. Maybe I should have started the way we did in class. Go find the question. The question tells you your variables. Write and solve a system to determine the cost of 1 night of hotel accommodations and 1 pair of baseball tickets. So my coordinate, I can use X and Y. Maybe I use A and B for accommodation and baseball. Maybe I use H for hotel, T for ticket. You do it however you're going to do it. But however you do it, make sure you say what's what. A pair of tickets is Y. X is going to be my hotel. So 3X and 2 pairs of baseball tickets. 2Y. 556.40. Plan B. Hotel for 5 nights. 4 pairs of tickets. $973. Again, they're giving me a rate for both. We have 5 nights of this and 4 pairs of that for $973. You solve it however you want to solve it. What do you think's the path of least resistance here? Okay. Do you see how this could be eliminated with only 1 multiplication? I like that you said by -2. You could do the top by 2 and then subtract the bottom, but we ran into problems when we did that. We kept forgetting to subtract one of the terms. So I like the idea of doing it times -2. So again, I rewrite all the stuff. -6x minus 4y is, what's that, 11, 1280? Check me on that. Okay. And lo and behold, not only do the y's go away, but I get just -x is, what's that, 27, 2980? Oh, wait, that's negative. Yeah, -2980? Okay. Which I'll just divide both sides by -1. Oh, oh.
Wait, I got a
No,
139.
it's 139.8.
There's an extra 1 there. Oh, no. No, it's not. No, it's not.
That is.
Damn it. God. Okay, you got there. All right, x is 129 or 119? No, 139. Okay, 139.80. Okay, so we got x. I'm going to forget if I don't tell her right now. Next class is Monday, and I don't have any meetings right now. Okay, Monday. Okay, so back here, 5 of those, 4y, 973. Plug it in. I hope you got a good calculator on hand. What's that? 500, 650, 695 for 699? Yes, no? I don't trust myself anymore. Ah! Didn't even do that, no problem, but we can't just do basic subtraction. 699 plus 4y, 973, is who what? Oh, remember it was a -x and then a -139, so we just multiply both by -1. Subtract your 699. What? No, back here we had okay, I didn't show my step because I erased it. They were both negative. So then when I divide both by -1 or multiply both by -1, that's when I get the x is positive 139.80. Okay. I had that step up there. I erased it. I panicked. I was wrong. I was wrong. Okay. Get rid of this, and we got 4y is 74? Right? 374? 274. 274. 6 turned into a 9, literally in front of my eyeballs. All right, divide. I don't trust myself anymore. 68.5. And because this is talking about money, let's turn it into 68.50. So write and solve to determine what one night at the hotel is. 139.80. what one pair of baseball tickets is. $68.50. Right now? Oh, well, baseball's a dying sport. Their attendance is trailed off hard, like even in comparison to other sports because of the pandemic. I'm waiting for them to start letting people tackle the guy who's running between bases, just to spice it up a little. But those are actually about right. Now, $68.50 for baseball tickets in Boston, where the fans are rabid, probably not. Probably more like 200. Okay, and then a little bit of review from back in the day. Okay. A little bit of review from back in the day. I want you to lock it in for this. I am not going to have you do this one on the test. Because by time, I still want you to focus on the other 5, the system stuff. I still want to review stuff, though. Okay? So you're going to do the 5, and because they're all fairly involved, they're all just worth 6 apiece instead of 5 apiece. Do you even remember how to do these? Okay, it means absolute value. The idea is that is greater than. Pac-Man eats a bigger one.
Yeah, that's right.
Absolute value is distance from 0. Distance from 0 happens in 2 places. Remember light side, dark side? Oh, but I have to get the absolute value thing by itself first. So I start by getting this thing by itself. Zero it out. It's still not by itself. I divide both sides by 2. Getting absolute value of x minus 1 is greater than or equal to 3. They're saying this thing is more than 3 units away from 0. So at 3 and -3, that thing is somewhere out that way. So that becomes your split. You go to the light side, keep everything the same. Say x minus 1 is greater than or equal to 3. Add 1, add 1. X is greater than or equal to 4. But on the dark side, everything is opposite. Everything has its meaning twisted. So this x minus 1 is not greater than 3, it's less than or equal to -3. You have to change the sign and flip the inequality. Add 1 to both sides. And if you remember how to graph those, close circle, more ink here, more ink there, everything to the left of -2. And close circle, more ink here, more ink there, everything to the right of 4. Open circle when there's less ink. If I have x less than 2, then less ink here, less ink there.
Is
Okay.
is that a big part of math? This greater than equal to less than.
I put this on here to review because we are literally talking about linear inequalities and graphing them next week. You will not do this one on the test. I wanted to review it because you're talking about it again next week. Okay? So, devices over there. I'd say we're fairly well spread out unless one of you in the middle wants to... Oh, wait, no, Joe's here. Yeah, we're spread out enough. We're good. What?
Browning